Welcome everybody to today's webinar, MAR for Mining, brought to you by the Australian Water School. And we're so glad to have Jason, Karen and Declan presenting for us today. My name's Trevor Pillar. I'm the National Partnerships Manager here at IceWarm and will be chairing this webinar today. Thank you so much for joining us. There's tons of people across the globe. You can see there the flags in each country. We're so glad you've joined us. So good to have a discussion of this size, and we'll get right into it. But just before we do, you can see here the free webinars coming up. I won't go into them in detail. There's a ton of them there, and also there's some online courses we're running here at IceWarm under the Australian Water School, and some face-to-face courses. We'd be glad if you wanted to log on to them. Come onto our website at icewarm.com.au and log on and register for those opportunities for training, capacity building. Well, so glad now to introduce to you Jason and Karen and Declan. They're here. Yes, good, great. Declan, thank you. You've joined us from CSIRO, and Jason from Golder, and Karen there in faraway Perth. Jason's a hydrogeologist at Golder Associates and 17 years of experience as a hydrogeologist, both in government and in private. Karen's a principal hydrogeologist and geochemist with 20 years MAR experience. We've worked together a lot, presenting courses in the past on Managed Aquifer Recharge. And Declan Page from CSIRO, Group Leader in Environmental Contaminant Mitigation and Biotechnology, in the International Research Leader. These are three very experienced professionals, and I know that you're going to enjoy the time together today. But right now, it's over to you, Jason and Declan and Karen. Thanks very much for joining us.
Thanks, Trevor. And thanks everybody for attending today. It looks like a good turnout. So water management is a key issue for the mining industry. Water that's produced during mine dewatering is no longer considered a waste product and something that can be just discharged off-site down the creek. And as such, there's expectations by regulators and stakeholders that any water produced during mining is managed in a sustainable manner. So as a result, MAR is becoming recognised by mining companies as a practical solution for managing their excess water. So MAR allows excess mine water to be recharged back into the source aquifer. Today, there's probably, in Australia, there's probably around about 100 MAR schemes operating. The vast majority of these is for stormwater harvesting and banking, for summer recovery through aquifer storage and recovery schemes. But over the last 10 or so years, a large number of mines have adopted MAR as a practical solution to managing their excess water. So I'm a hydrogeologist at Golder. We've partnered with several mining companies to deliver MAR projects, mostly in South Australia and in Victoria and on the eastern states. Each of these projects has been unique and technically challenging, and we're still learning a lot. But it's important to recognise that the development of a MAR system requires a broad range of expertise, not just in hydrogeology. So joined here today with Karen Johnson from Managed Recharge and Declan Page from CSIRO, who are also, they've got a lot of expertise in Managed Aquifer Recharge and in matters relating to geochemistry, water quality, clogging, the operational management side of things, and risk assessment. And so they will jump in and talk on certain aspects and be available for any discussions afterwards. So today's presentation it's not a technical talk, it's just a high-level overview of MAR and mining, touching on things such as what are the benefits MAR can bring to mining, broad overview on the hydrogeological conditions that may influence MAR feasibility. We'll run through some of the stages that you need to think about to develop up a MAR scheme. And then finally, we'll talk about some of the challenges for Managed Aquifer Recharge and mining, which will lead into discussion. So what is MAR? Well, it's the intentional recharge of an aquifer by injection and followed by planned extraction. But aquifer recharge may also be used for environmental benefit where there is no extraction. So in a lot of cases, you've got mines and you're dewatering and you're lowering the water table, which poses risks to any nearby groundwater receptors. So MAR can be used to offset some of those impacts and allows mining to operate in areas where there are other groundwater users and groundwater receptors. And Declan's got some really good examples of that, where mines are operating in sensitive areas and using MAR to offset any potential impacts. Other terms that are often used is managed aquifer injection. It's more suited to where it's just pure disposal, where there is no recovery. And there's probably a couple of other terms that people use, but I recommend always checking with local water policy or legislation to see what terms they use and to be consistent with the local policy and regulations. MAR has come a long way over the last 30 years. There's been a rapid development in MAR and a lot of investment from government and the private sector. And there's a broad range of applications, which a number have put up there. In Adelaide, South Australia, where I'm from, there's 58 MAR systems operating in Adelaide, and they range from small scale injection involving perhaps one injection bore to larger scale injection where there's 6 to 8 injection wells. So what are the benefits that MAR can bring to mining? Well, when it comes to mine water management, mines have two issues. They've either got too much water from mine dewatering, more than what they need for processing or for storage on site, or not enough water where they need to bring in additional water. Where they've got too much water, MAR is useful for disposal. So some of the projects that we've been involved with are mines which are zero discharge sites, where the regulations prohibit them from discharging any water off site. So any water that they produce on site needs to be managed on site. So MAR has been quite useful to help them dispose of water on site. The other issue I said is mines often don't have enough water, and MAR is also can assist in that circumstance, where you can replenish aquifers that are being used for groundwater supplies to provide greater security for your groundwater supply. So there's an example that we're working on in Queensland, where the aquifer has got a limited size, a limited extent, and the client's looking to replenish that during the wet season through MAR to provide greater security to the groundwater supply. And the other benefit is to offset groundwater related impacts, which I mentioned before. So there's just a figure at the bottom there showing groundwater level flowing towards a river. You then start mining and mine dewatering, and you create a cone of drawdown that spreads out towards that river and starts impacting on base flow and reducing base flow contribution. And then you can start injecting that mine water and offsetting that base flow loss to the river. Declan's got two examples after this that he will share with you. The other benefit of MAR, when you compare it to other water management options that are sometimes utilised by mining companies, such as big evaporation basins, which take up a lot of area and expensive to build, or desalination, MAR is often cheaper and has a much smaller footprint than those other water management options. So they're the main benefits, and I'm sure other people can think of others that are more suited to their mine sites. But the next two slides, I'm just going to hand over to Declan now. He's going to present two case studies where MAR has been used to benefit the environment.
Thank you, Jason. I've got an example here of the Cloudbreak mine in the Pilbara in WA. This is an example courtesy of Fortescue Metals Group. You can see here a cross-section. On the right-hand side, you can see the pit that requires dewatering. And on the left-hand side, a sensitive wetland. And so as the mine is progressing on the right-hand side of the screen, up and mining through the seam of iron ore, they're slowly, drawing water away from this wetland. And so to offset that, as Jason said, they've erected a number of wells along the sensitive wetland and are now injecting their dewatered mine water in that. As they continue to mine, they slowly, fill their pits, and they move their injection along. And the important thing I'd like to highlight here is this was the only way that they could protect these water sensitive ecosystems, and thereby get a license to do this type of mining. So it was a vital part of this mine. Here's another example. This is an example from Santos. We've also, CSIRO has been involved with the coal seam gas industry a fair bit through a project called Jazeera. And on what I like to show here is on the x-axis, you can see the date, and on the y-axis, you can see the volume. So I'd first draw your attention, this is around a small town called Roma, which is in the centre of sort of Queensland and western centre Queensland. It's very dry there, and they depend on their drinking water supply for groundwater. And you can see the purpley pinky line with the square dots is Groundwater Aquifer, and that's their drinking water source. And you can see on the right hand side there's been, which shows the metres below ground, and you can see there's been a steady I guess decline of the groundwater resource from about 1980 to the year 2000 or so. And this is natural decline just because it's a very dry area, and of course the town's using a lot of water. However, at the same time, you can see the consumption, which is the red triangles, is going to be increasing over time. So there was an opportunity identified that to prevent this groundwater decline, you could inject what's called the associated water production, and this is the water that is produced during the coal seam gas extraction process. So it's a bit different from the other mining example, where they inject water, where they dewater the coal seams to get the gas, and this water is then extracted to the surface. It is cleaned by reverse osmosis, and then they have I guess they've disposed of it in a number of methods. Some of them have included disposing to local waterways, but this, of course, radically changes the ecology of the system. It has also been used for horticultural enterprises, but they have quite a limited life. And you can see really that this water will only be around for about 10 years, from about 2010 to 2020. And so any enterprise, this water will only have an availability during that period. So as another option was to inject this water into the local Groundwater Aquifer and thereby bolster the Rome town water supply, which has been declining for a while anyway. This was seen as a way to, I guess, protect the resource and also have a high value beneficial use, that being drinking water. And here we're talking about 340 gigalitres over the period of this 20 years or so. I think that's it for me. Jason, you can take it back now.
Thanks, Declan. And yeah, that's just a couple of examples of how MAR can benefit the environment. Yeah, so when selecting an aquifer, there's a number of factors to consider. These are just a couple of them. Fractured rock or unconsolidated aquifers, both are suitable. There's the perception out there that fractured rock aquifers are not suitable for MAR, but owing to the limited storage and things like that. But they are suitable. Just requires a bit more investigation, and there's a few additional challenges with injecting into fractured rock aquifers. You can inject into confined aquifers or unconfined aquifers. Obviously, if you're injecting into an unconfined aquifer that has shallow water table, there's a higher risk of water returning to surface during injection. So if you've got rising groundwater levels near the surface, you can get water logging. If the groundwater is saline, you can get sedicity, which affects soil structure, and you can start impacting any native vegetation. So there's a few things you need to be mindful of when you're injecting into an unconfined aquifer. When you're injecting into a confined aquifer, you can inject under pressure, but you need to have regard for the overlying confining layer. You can't overpressurize, you can't inject at very high pressures, which cause hydraulic fracturing of the confining layer, and you can cause that confining layer to fail and induce leakage from the confined aquifer up into the unconfined aquifer. So that's one constraint that needs to be considered if you're deciding to inject into a confined aquifer. Obviously, aquifer transmissivity is very important. High transmissivity will allow higher rates of injection, and it will also promote the lateral spreading of recharge water. And groundwater quality, so that is in mining, that's a very important constraint. So mine water contains high levels of nitrogen or from blasting or heavy metals, and so you need to consider the water quality of the surrounding groundwater. Typically, you're restricted to injecting water that's better quality or equal quality to the surrounding aquifer. Otherwise, it may be viewed as a waste. And the other factor to consider is groundwater receptors and other existing users and where they're located. I gave that example before about the potential impacts of waterlogging to vegetation, but you also need to consider private users. Obviously you don't want to be injecting in close proximity to private wells because there's a potential that you could cause those wells to become artesian. So that's just a range of factors to consider, and there's several others. Move to the next slide, please.
So Jason, I wonder if we could just have a pause. That'd be a good place to pause. There's a couple of questions coming up that might be useful. We'll go into this next process, stages of Mars system development. But Matt Polizzi, I believe from where is it? Matt from? Osmoflow. Yep. How does MAR differ from ASR? It's a pretty standard sort of bigger question, overview question. What would you and Declan and Karen, what would you say is the difference between MAR and ASR?
Well, MAR in mining is looking at injecting water, and that may have a beneficial impact to a positive impacts to surrounding receptors. But ASR is aquifer storage and recovery, where you recharge the aquifer and you recover that afterwards.
So a specific recovery issue in ASR. That's not so in MAR. And MAR is the more global way of talking about aquifer recharge.
That's right, yeah. The concepts are the same. Yep.
Okay, yep. Uriana from Indonesia. I'll ask one more question here. I think it's worthwhile going into this. She's a lecturer in university in Indonesia. Has said MAR is cheaper than desalination, but is it more reliable in quality assurance? And if using treated wastewater for water injection, is the treatment very expensive?
Yeah, that's right.
Two questions there, Jace. So Declan,
it's not. It's definitely. It's not always reliable, and Karen will talk a bit about this as well. There's a lot of there are risks, especially associated around clogging. That's one of the biggest risks to MAR and mining. And obviously, you need to look at the quality of the mine water and the receiving aquifer and see what level of treatment may be required prior to recharge. And if you need a high level of treatment, which at a higher cost, then it may make the scheme unfeasible when compared to other water management options.
So any comments from Declan? Karen, you might have to turn your mics on. Yep. Any comments from yourself, Karen, Declan, on that issue?
Yeah, I would say, look, in all cases, wastewater needs to be treated, and it's just a matter of, I guess, deciding where the receptor goes. I mean, where you're going to send the wastewater, then the sensitivity of the receptor, and hence the level of treatment required. So MAR's one option, and there may be others as well.
Right. Cheaper than desalination, more reliable in quality assurance.
Cheaper than desalination, definitely, by probably an order of magnitude.
There we are, Uriana. You've got that directly from.
Is the treatment expensive? It depends.
It depends, yeah. Right, yeah. Is the treatment expensive? Yeah. Depends.
In some cases, for example, Perth, they desalinate to inject wastewater.
Right.
I'm sure Karen can talk to that.
Indeed. It's, but every site's different, and you have to work through the process to see which is your option. You shouldn't just say MAR is it and try and make it fit. You need to assess the options.
Yep, no, thank you. Look, Emma Thompson Brewster has got a reasonably long question here, and I wouldn't mind raising it at this point. It's early, I know. Brisbane in Queensland, Australia, where MAR is used as water management method for zero liquid discharge mines. What are the possible problems and regulations around contaminants in MAR water getting into the surrounding environmental groundwater surface waters? That's the first question. the second bit goes, you already mentioned some common contaminants of mining waters being salinity, nitrogen, and heavy metals. How is this commonly regulated and managed? So I don't know whether you've got your Q&A screens up, Jason, Declan, Karen, but that's a pretty comprehensive comment and question that probably many need to address.
Yeah, I guess any injection of mine water needs to have regard for the existing environment, and we'll touch on that in the following slides where we go through the regulatory process and the groundwater modeling that's involved to assess some of those risks and the migration of recharge water and whether that poses any risk to environmental receptors.
Yep.
So we will touch on that a little bit in subsequent slides. Yep.
So no, all right, then we might leave it at that then, and just keep that thought, Emma. No other comments, Karen, Declan, on that one. Should we just press on? Yep. Okay.
Yeah.
All right.
And the other thing I just want to add is that MAR is not always the one solution when it comes to mine water management. It could be one tool used with a combination of other options to manage their water. So a lot of the mines that use MAR have other options as well.
Yep. Karen, you had a comment?
Yeah, I did. While it's not always the case, oftentimes mining is conducted in areas where groundwater quality is already pretty poor. And so because mines are located where there are lots of metals, oftentimes groundwater is already heavy, got a lot of heavy metals associated with it. So to manage it, you monitor what's there before you inject, and you monitor what's in the water that you want to inject, and you make sure that it's compatible. So the rule that Jason mentioned earlier, that you don't recharge with any water that's of poorer quality than what's already there, is a pretty standard rule and the sort of thing that you would investigate in your pre-feasibility and stage 2 investigations.
Yeah. So lots of monitoring, lots of data gathering, and not putting back in the ground worse quality than what's already in there. Yeah.
Indeed.
No, that sounds good. Yep. No, thank you. All right, back over to you, Jason.
Yeah, thanks. So this is just an overview of stages of MAR development. So there's some of the stages that you'd go through if you're developing up a MAR system. You'd start off with a desktop study where you review all your available information, and we'll touch on that in a minute, to get a feel for whether MAR is going to be feasible for your site. And, we adopt a staged approach. And so that as part of this desktop study, you might identify factors that may make the project unviable. And then at this stage, you can make a decision whether you want to continue before you make significant investment. So if you do the desktop study, after that, if it looks like the site is favourable for MAR, we recommend that you commence discussions with the regulators at the early stage, because if they identify issues that they're concerned about, then you can address those issues into your forward work program, so you don't get any sort of regulatory surprises at the end of your investigation. After you do your desktop study, you go through aquifer characterization, so you may include drilling at a number of locations to evaluate aquifer conditions, different locations around the mine. If that looks prospective, you can do a pilot trial, injection trial. After that, you go into your numerical modelling and geochemical modelling to help assess the risks. That's a regulatory requirement that helps you understand, all your groundwater related risks and help predict how the aquifer will respond to injection over a longer term. After that, you do a risk assessment and groundwater management plan, and Karen's going to talk more about that. It's all about identifying all the risks and working through how you're going to manage those risks. From there, you develop up your functional design, and that's really sort of a blueprint of what your MAR system will look like in terms of number of injection bores, where they're located, their spacing, their injection rates, operating pressures, your pumps and pipes, and your monitoring infrastructure. And then you bundle all of that together, and then you can meet with the regulators and go through your regulatory approvals before you start spending money on detailed design. After your detailed design, you go into your construction and your commissioning phase. And then there's always ongoing monitoring and management of the system. Monitoring and management, and Karen will talk about that as well. It's just to check that the scheme is operating as expected, and just to check the performance of the scheme. And as I said, Karen will touch on that in a bit more detail. But that is, in a nutshell, is the process that one will take if they're developing up a MAR system for their site. Next slide, please. So we'll just touch on each of those processes just very quickly. Stage one is the desktop study. So what we'll find is that mines typically hold a large amount of information to help assess MAR feasibility. So obviously mines, they have a geological model, which we can use to help our conceptualization of the groundwater system. There's a lot of drill hole data through exploration. You review geological logs, RQD, drillers logs, and things like that. And that helps us characterize the aquifer in a number of locations and identify potential locations suitable for injection. Obviously, we've talked about mine water quality and groundwater quality. We can compare the mine water and groundwater quality to see how compatible they are and what level of treatment may be required. This will help understand what sort of cost may be involved if you were to look at doing MAR. And obviously, you need to take into account the mine plan. Mines, they're always expanding, putting new tailings dams in. Sometimes there's competition for space with these injection bores, so you want to take into account the future mine plan and infrastructure. And then the other big factor is groundwater receptors. As I said before, it's important to identify the groundwater receptors. You don't want to be siting your injection bores in close proximity to private users and cause their bore to become artesian. You need to have regard for groundwater dependent ecosystems, or, as I said in the earlier slide, be mindful of the impacts of rising water tables on any vegetation. So there's a lot to consider when assessing MAR feasibility and identifying sites for injection. As part of the desktop study, it's also important to review local regulations. And as I said, start meeting with the regulators as early as you can to get a feel for what their concerns are so that you can feed them back into your forward work program. And based on the above, you identify any key risks and data gaps that need to be addressed as part of your stage 2 investigations, which is your aquifer characterization. Now, once you've gone through this desktop process, you'll get a feel for how feasible MAR might be and perhaps the cost. You may get a feel for how many injection bores you may need, what sort of treatment you may require, and all of a sudden you can start understanding what CapEx may be involved, and then you can use that to compare against any other options that you're considering to help you with your business case. Next slide. So stage 2 is aquifer characterization. This often involves drilling investigations. What we usually do is drill at a number of locations that were identified during the desktop study. You might drill, 1, 2, 5 or more pilot holes at each of those locations to understand aquifer conditions at each of those sites. And then what you might do is look at that information and identify what site may be best for installing an injection well. You might go back to one of those sites and install an injection well for the purpose of undertaking a pilot trial for injection. At this time, you'd also be doing baseline sampling to characterise the groundwater levels and groundwater chemistry if you don't already have that information. Once you've constructed your injection well, you might do a pumping test to understand the aquifer characteristics a bit more. And the good thing about a pumping test is they also provides a preliminary indication of how well the injection well may respond under injection. If that all looks good, then you may take it to the next stage and undertake an injection trial. Now, injection trial may be short-term, 1 day or 3 day, or maybe a longer-term 90-day injection trial. You may involve injection to one well or multiple wells, but the objective of the injection trial is to assess any operational constraints and address any technical uncertainty, which could be about the size of the aquifers and how much water it can receive, operating pressures, clogging, the risk of upward leakage. So really, that stage, you're really understanding any operational constraints and reducing any technical uncertainty before you spend much more money in upscaling to development of other injection bores. Top is just a picture of drilling, and bottom was a picture of just an injection bore with the results from an injection trial. We've got monitoring pressure in the injection well and the groundwater level in a nearby observation well. And Karen will talk about clogging in a bit more detail, but during the injection trial, you'll get to look at the aquifer response, detect whether any clogging has occurred. In this case, it did towards the end. See a sharp rise in groundwater pressure, which which indicates some sort of clogging has taken place. Next slide. After you've undertaken your drilling investigation, you've done your pilot injection trial, and if that all looks good, you want to start thinking about regulatory approvals. Regulators in Australia often require groundwater modeling to be undertaken. Groundwater modeling allows you to assess the aquifer response to longer term operations, allows you to simulate both mine dewatering and also injection, and simulate some of the risks, or assess some of the risks, such as the development of artesian conditions, the risks of upward leakage. You'll be able to simulate the movement of recharge water and the risks that may pose to surrounding receptors. And groundwater modeling is also a good way of informing what additional groundwater monitoring may be needed, and the setting of the groundwater triggers for the prevention of groundwater related impacts. The other good thing about groundwater modeling is it can be used to help you understand your functional design. So you can use groundwater modeling to assess a range of MAR scenarios, such as how many bores you may be required, their spacing. So it's a good tool to sort of inform a different range of MAR scenarios. Next slide, please.
So we've got about 20 minutes left. Yep. So we might just keep the speed up a bit. There's a few questions on deck here.
I think we've got 3 more slides anyway.
Oh, that's okay.
So,
yep, that's great.
I was going to.
Thank you. Yep.
Now I'm going to hand over to Karen to talk about geochemical and biological assessment for MAR.
Okay. I saw that geochemical and water quality issues are quite topical. People are interested to know what the issues are. It can be addressed best in a risk assessment type process. You mentioned earlier, Jason, that When you're doing stage 2, your investigations, you would get yourself background data on what the groundwater quality is before anything occurs, and you would, where possible, collect water quality data for your source water, and you have a look and see how similar or dissimilar those different water qualities are, and have an assessment of any issues that might potentially occur. So Jason's mentioned in mining industry, oftentimes the water's got high total nitrogen because of the blasting. We know from experience that high nitrate can induce biological growth within the bores, and you can see down in the bottom right-hand corner there's a bore with a biological flock on the well screens, which has been induced through microbiological growth associated with the nutrient-rich water. You might have inorganic chemicals. Typically, if you're pulling water out of a mining pit, you're mining there because the ground is high in metals of some kind, and it's not unusual for those metals to also then be found in the groundwater as well. So you will have to have a look at the aquifer you're proposing to recharge back into. If you're putting it back into the same aquifer, then often it's not necessarily too much of an issue. Those elements are already elevated in the groundwater anyway. But if you're putting it into a different aquifer, then that is something you would really need to consider carefully and adjust the monitoring program accordingly. So a lot depends on the aquifer you're putting it back into. Same aquifer, or perhaps a hypersaline paleochannel aquifer, for example, is often used in the mining context, then the water quality isn't a huge issue, just because the water that's being recharged to has no beneficial purpose. So these are the sorts of conversations and consultation you will have with your regulators when you're thinking about the project. Conversely, sometimes if you're putting fresher water back into a saline, a brackish or a saline aquifer, you might induce some dissolution type reactions, and you might actually find that metals are mobilized that were never there in either of the sources previously. So it's not uncommon for arsenic or lead or cobalt and other heavy metals to be released in these systems. And so Jason showed that you undertake XRD analysis, for example, during drilling, and XRF analysis, so that you can find out precisely what minerals and elements are present in your aquifer matrix. Because if they're not there, then they're not going to be an issue. You don't need to necessarily monitor for them indefinitely. So what the Australian MAR guidelines recommend, and it's a good approach for mining as well, is that you really characterise well your systems and identify the risks, and then put your monitoring program around those risks. So sometimes what you find is you will sample and analyse for a range of parameters as long as your arm, and the important things get lost in the bulk of data. So targeting your monitoring program to the risks is really more cost effective, and at the end of the day will address your risks more adequately than just sampling for everything. Will you need pre-treatment? Potentially, if you've got biological clogging, you might need to introduce a biocide, for example, into the bores to prevent that clogging. But then again, you have to be careful that you're not generating an oxidation reaction within the aquifer and releasing heavy metals. So all of these things are factors that you need to consider and assess carefully before reaching a conclusion as to what action you're going to take. Also, we know for a fact that sometimes when you recharge water with elevated levels of bacteria or perhaps have elevated nutrients and even metals, those potential contaminants can actually be attenuated in the aquifer, and the aquifer itself acts as a buffer or a treatment. So as the water moves through the aquifer, the bacteria might die off, the nutrients get eaten by bacteria and are degraded in the aquifer itself, or the metals might be absorbed. So this is a good reason to have monitoring bores at your site so that you can sample and actually see what is happening in the aquifer and take a bit of the guesswork out of it. Next slide, please, Trevor.
Can I just interrupt? There's a really interesting question from Hugh Middlemas at Hydrogeologic here in South Australia. Hugh's asking, when were the Australian MAR guidelines published? And are they national or at least applied and endorsed in each state territory? And can we access a copy?
Oh, yes, absolutely. The National MAR Guidelines is very, very shorthand for, as you can see on the slide here, the Australian Guidelines for Water Recycling, Managing Health and Environmental Risk, Phase 2, Managed Aquifer Recharge. So it's a bit of a mouthful, but it's got all the details that you need in there. It was published in July 2009, and you can access them very easily on the internet. Just type in a Google search and you'll be able to find where you can download them. They're a really handy tool to have. It focuses your approach to investigating and establishing operations based on key risks. So it's a really useful tool for focusing resources, both financial and human resources, towards things that are likely to be an issue rather than maybe.
Yeah, thanks, Sharon. The other part of Hugh's question goes to the endorsement application throughout national and state and territories.
Okay. I know in Western Australia, the Department of Water and Environmental Regulation have a policy, MAR Policy 101, that specifically references the national MAR guidelines and expects you to implement, at least incorporate the risk assessment elements into your studies. I believe South Australia may as well.
Jason.
Yeah, and likewise with Victoria.
And Victoria. Okay. I don't think New South Wales or Queensland, but Declan might know better than me.
So the National MAR guidelines sit under the National Water Quality Management Strategy. You can find it on the Department of Ag's website, but they do move around a bit as the federal government changes its departments around. They're written in 2009. It took a while for each state to adopt them, and slowly states have been adopting them. So WA has had to adopt them because of their forging ahead with indirect potable reuse and MAR. SA's, we've had a long history of MAR here, especially with stormwater recycling and karstic aquifers. And again, each of these has then been, I guess, adopted to various degrees in the state-based legislation. So here in SA, it's with the EPA, and different departments hold, I guess, carriage of how water is managed, both in terms of health and environment in different states. So it differs slightly, but most of them have slowly or are in the process of moving towards adoption of these or very similar practices.
Yeah, no, thanks a lot for that, everyone. Look, I think we'll just press on. We've got about 10 minutes left. There's questions coming up on the board as we speak, but maybe we just let's proceed a little further before we go back to the questions again. Thanks, everyone. Thanks, Hugh, for that question. That was great. Back to you, Karen.
Okay, so the National MAR guidelines are really focused on using a risk assessment approach to assessing and managing Managed Aquifer Recharge. And it really helps you focus on identifying key risks and then identifying mitigating strategies. What are you going to do to monitor those risks and manage those risks? So the guidelines themselves highlight 12 key risks associated with Managed Aquifer Recharge in general. I've just picked out a few of them here that I know are particularly pertinent to the mining environment. And as soon as you start recharging an aquifer via an injection bore or a well, you're going to have clogging. So that is a high risk, and it is pretty much across the board. So you then work into your program, what are we going to do to manage that clogging and mitigate against it? So, for example, you might install some injection lines, make sure your water is being delivered below the water table so that you're not generating air entrainment. You may require filtration. It's definitely an additional expense. It's definitely an additional headache operationally. But if you don't have filtration at the surface and some kind of filtration treatment, then your bore will do it for you. So you'll put that water down, and the suspended sediments that aren't being filtered at the surface will get filtered around the bore in the bore aquifer interface, and you'll find very quickly that the sediments will be filtered out, form a filter cake, and your bore will not accept the amount of water that you anticipated that it would, and you will get pressure build-up and potentially damaging to your confining aquifers or the bore itself. So filtration, while it might look difficult, is oftentimes a useful thing to incorporate into your program, as is a maintenance program. Be aware that you will need to go back and redevelop these bores. Make sure that you don't shut off access to these bores. You can get a rig back in there and redevelop them. And also have some standby capacity. No mine manager is going to want to say, sorry, can't get rid of the water today, let's shut everything down. So make sure you've got bores, injection bores ready to go should something happen to any of the ones that are being used. Another common risk in mining environment is water expressing at the surface around the bores. If you do get a bore that gets clogged and water comes up and expresses at the surface around that bore, then particularly if you're recharging a hypersaline or saline water, you've got a risk to the local environment around those bores. So you would mitigate against that risk by ensuring that pressure and water levels are being monitored in that bore, and ideally you'd have an automated shutdown system should that water level pressure reach such a level that the risk is going to happen, then the system shuts down for that bore. And the last one that people kind of leave to the end and don't think about too much, but it's quite a high risk, is what is your operator capacity? Who's going to be running these systems? Because you really have to have someone who is over how the system operates, what it's doing, and the sorts of things that they need to look out for to make sure it runs well into the future. So do you have a training program? How are these people being informed about the system? So there's some of the key risks and how you might mitigate them. Next slide, Trevor. You use the information from your stage 1, stage 2, and your risk assessment to develop up a functional design. And I think Jason ran through that earlier, so I won't necessarily go through it again. I'll let Jason have it back.
So yeah, these are the main challenges, and there's obviously there'll be others, but one of the biggest challenges is continuous injection compared to aquifer storage and recovery. So a lot of times you're not recovering the water; you're just injecting 24 hours a day, 365 days a year, and obviously the aquifer's got to be of sufficient size to be able to handle that demand. So that's one challenge, and especially in fractured rock environments where there's limited storage. Clogging, we've already talked about a lot. Karen has talked about that a lot. Mine water quality, we've talked about that as well. And Karen just talked about resourcing MAR operations. One thing we didn't talk about is recirculation back towards the mine. That's one thing that could be assessed through groundwater modeling as well, is how close to the mine can you inject, and where is that water going to end up? Are you just going to end up pushing water back towards your mine? And one of the challenges that we face with some of the schemes that we're setting up for mining companies is how do these projects integrate with existing water policy? One example might be a mine operating in an environment where all the groundwater allocations, there's no groundwater allocation. So they pump dewater and inject straight back into the aquifer, and there's actually no net groundwater use, but still, mines are required to have a groundwater allocation. In some cases, there's not enough allocation to support the dewatering, but they're not actually using the water; they're putting it straight back in. But again, that situation doesn't always comply with some existing policies. So, yeah, I think a lot of some of the issues that we're having is how do we integrate these projects with existing policies which are set up more so for aquifer storage and recovery, and there's been no, appetite to update them to consider MAR and mining. Can you add anything else, Karen or Declan?
Sure. I'd have to say that clogging is probably the single greatest operational risk in terms of running MAR schemes, and the single greatest cause of MAR scheme failure. So it's a really important thing. That falls into, I guess, the water quality requirements for different aquifers, and that can differ from aquifer to aquifer, and as well as, I guess, the different treatments that might be required for a sustainable MAR system, especially if you're going to use continuous injection, as Jason has commented above. So I just want to flag that's a number one issue, and there's still a lot of research to be done in that to determine what and how of, I guess, sustainable MAR systems.
Yep. Any comment, Karen?
No, I just second what Declan said.
We're about 2 minutes out from finishing here, and the board is full of questions, as you probably see, presenters. One that stands out here by Roger here in South Australia: does the panel know of any nice examples where large-scale MAR has won out against proposed surface storage option for drinking water or irrigation supplies?
Yeah, I'd say, well, in Perth.
Yeah.
Where is that again?
In Perth.
Yep, right.
So Perth for drinking water, and the other one would be in the Burdekin Valley in Queensland for irrigation supplies. Yeah,
two very big ones.
Sorry. Perth is currently operating a 15 gigalitre per annum scheme at the Beanyap groundwater replenishment site, and they're upgrading that to 28 gigalitres per annum. Right. But it is a ultra purified source, so clogging is not an issue.
Not an issue, yep. Look, we're going to have to close here. There's Michael Jemison, thanks for your comments about there being NWQMS was produced, quality was produced, which included all states, and therefore it's a document endorsed by all states. So thanks for that comment. And also you've commented about, Michael, about the types of laws that apply in each state in relation to MAR. That's the main question, I guess, and where the difference exists between states. So I'm just skimming across these couple. I won't skim anymore. Hugh, thanks for your comment about the informative webinar. I appreciate that, and also the direction you've said. Thanks also for the MAR guidelines you've said. We're going to have to halt this because we're hitting the 60-minute mark, and we could go for another many more hours on this. And in fact, we are thinking probably to run this as an online course, but we'd have to get your ideas about that. You'll see on screen right now that there's a poll as to whether you'd be interested in. Yes, thank you. You've already done it. Everybody's straight into that. Okay, yes. Well, 60 to 70% said that yes, we'd come to an online training course. Okay, we take that on notice, and my colleague here, Joel, is looking at that very carefully, and we will also. So stay tuned. We will come back to you with an offer for online training. So I think we will have to say that's probably it for today. You've seen that screen there with a ton more free webinars coming up. Jason, Declan, Karen, it's been authoritative. You've got the experience to boot. We've really appreciated your time today, and hopefully we'll come back to this in another format, not just a webinar, but a bit longer to actually deal with the issues that have been raised so well here by so many people, and we haven't got to them. So thank you. Much appreciated, Jason. Thank you, Declan. Thank you, Karen. And for everybody who joined in today, there was a very big listening audience. Thanks again. Goodbye. We hope to see you again at a future webinar.
Yep. Thanks to Iceform.
Thanks. Thank you.
Yeah.
Bye.
Bye-bye.